Hello and welcome to this video in our series, A Beginner's Guide to the C Programming Language. In our last video, we discussed the software development lifecycle, where we walked through the process of developing large applications. In this video, we will discuss the concept of data types and how they are used to declare variables and constants. We will also start doing some hands-on practical demonstrations using an integrated development environment or an IDE. An IDE is a tool used to develop applications in a programming language. We will create a simple project and then add some code, build it, and then use the debugger to help you understand what is going on under the hood. So before we start, please follow us, like and share this video, and enable notifications to keep up to date on our channel. Now, what are data types? We know that there are three kinds of data stored in memory. The first kind of data is primary data, like characters, multi-byte integer numbers, and real numbers. The second type of data is derived data, which is a collection of primary data types, like strings, arrays, structures, unions, etc. The third kind of data is structured data that consists of primary and derived data in a well-known format used to represent complex objects like images, documents, etc. Now, different languages have different set of data types that are used to create variables and constants. For example, a low-level language like assembly language only has primary data types. Therefore, processing more complex data objects would take a lot of coding and testing effort. On the other hand, a high-level language like Python has complex data types like sets, tuples, lists, etc., which allow you to perform operations on these objects using inbuilt functions without the need to code it yourself. Now, in between these two types of languages, you have C, which has basic data types to store characters and numbers. These basic data types are then used to create derived data types and user-defined data types. Now C is a statically typed language, which means that the variable's data type must be specified when the variable is declared. This defines the type of data value that can be stored, its size, and range of values it can contain. Also, in a statically typed language, the compiler will check the data type when it is used in any operation, performing any conversions if required. In a dynamically typed language, the variable declaration does not need to declare its type. The type of data is determined when it is assigned a value. Also, the variable has a fixed size in memory depending on the type of data it stores at runtime. As we have seen before, the C language has three different kinds of data types. They are the basic data types or primary data types that store characters and numeric values, derived data types like arrays, strings, and pointers, and finally, user-defined data types like structures, enums, and typedefs. The table here shows the primary data types of C. The data types define its size and range of values it can contain. The larger the size, the greater is the range of values. You should also know that a data type can also specify whether a number is signed or unsigned. The range of signed and unsigned values are different, as can be seen over here. The integer data types are char, short, int, and long. Each of these data types differ in their sizes and range of values they can hold. The important point to note here is that while the size of a char, short, and long is fixed, the size of an int depends on the compiler. A 16-bit compiler will allocate 2 bytes to an int, whereas a 32-bit compiler will treat ints as 32 bits. Since different compilers will treat ints differently, you must keep this in mind when declaring variables. You must choose short or long int data types if your variable declarations need to be portable across compilers. Now, integer numbers store whole numbers in 1, 2, or 4-byte formats. Real numbers are numbers that have a fractional part. They are stored in memory in the signed exponent and signed mantissa format. These numbers have two important characteristics, its range of values and its precision. A float data type is 4 bytes, where 1 byte is the exponent and 3 bytes is used to store the mantissa. A double is 8 bytes. It has a 2 byte exponent and a 6 byte mantissa, thus giving it more range and precision. Now, data types are used to create variables and constants. A variable is a named memory location that can be directly addressed in a program to access its value. Constants, on the other hand, only have values. When we declare variables, we need to specify their data type and variable name. The variable name is carefully chosen to describe what it contains. There are many variable naming conventions which you can use to make sure that your variable names are descriptive and self-documenting. When you declare a variable, the compiler allocates a fixed number of bytes to the variable. It may be initialized or uninitialized, depending from where the compiler allocates memory to it. We will discuss this in more detail in a later video on storage classes. The second set of examples shows different ways of how variables can be declared in C. You can declare a single variable or a list of variables separated by commas in one statement. You can also initialize these variables by assigning them a value. A single declarative statement can declare multiple variables and initialize all or some of them using individual assignment statements. Now let's look at constants. A constant is a fixed character, numeric, or string value that you use in your program. We will discuss how to specify the data types for a constant value. Now, numeric constants do it by using a suffix if required. The suffix includes L for long, F for float, and U for unsigned values. A prefix is also used to specify the number system. For example, the prefix 0x is used to specify a hexadecimal value. Octal numeric constants are prefixed with a 0. A character is a 1 byte value that holds the ASCII value of the character. A string constant is a collection of characters terminated by a special character called a null terminator. This is an important characteristic of a string in C. The null terminator immediately follows the last character in the string. In our earlier discussion on the ASCII table, we talked about the control code section. We know that these control characters are special characters that specify a status or a control action. In C, these characters are called escape sequences. They are character constants prefixed by a backslash, followed by a character specifying its control value. For example, the carriage return character has an escape sequence backslash R. The line feed control character has escape sequence backslash N. These escape sequences can also specify ASCII and Unicode values in hexadecimal. Now let's get practical and demonstrate how a C program is created, compiled, linked, and executed. We will also have an initial look at how to use the debugger. This course will use the Microsoft Visual Studio Community Edition, an integrated development environment used to develop C and C++ code in the Windows platform. It's a collection of tools, including an editor to create and edit your C programs, a compiler to compile your programs, a linker to link your project modules, and a debugger to help you find fixes for runtime errors. Other tools like the profiler, etc., are also available in this IDE. In this IDE, we can create a solution that contains multiple projects within it. A solution is a configuration of a collection of projects. Remember that the configuration consists mainly of the directory and other settings for all the tools used in the IDE. Once we start the IDE, we can open an existing project or solution if available. To create a new solution, click on the Create a New Project option in the menu. Then we need to specify the configuration for the project we are creating. We want to create a C++ console application. So we will select an empty project and click on Next. Now enter the project name. Next, select the location in your disk to store the project files. I would recommend that you create a directory which you can use to store your files. The third step is to enter the solution name and to select the checkbox to store the solution in the same directory as the project. Now click on the Create Project button to create the solution and the project within it. The screen layout shows multiple dockable frames. At the right is the Solution Explorer, which consists of the solution whose dependencies are shown in a tree form. The first level node contains the projects. At the left bottom of the screen is the output window, which has multiple tabs that show various info about the programs being compiled or edited. We will discuss more on this topic as we continue with our future practical demonstrations. The left part of the screen is the editor window, which is currently empty. Now, our first step is to create a source file which will contain our program statements. To do this, right-click on the project name in the Solution Explorer and choose to add new item on the menu. The Add New Item screen is displayed. Select Code in the left side tree and C++ file in the selection window. Enter the source file name and click on Add. The editor now contains an empty source file. You can now enter your code. Here is the final version of the code we have entered. All we have done is declared variables and initialized a few of them. Once the code is done, you can compile it by clicking on the Build menu, Rebuild Solution option. Building a solution will initiate the compilation and linking process that will create the final executable file. If your program is entered correctly, the build process will be successful and your executable file is created. In our later videos, we will cover examples of syntax and linker errors and show you how to fix them. You can now execute your program. To do this, you use the function F5 key to run your program or the function F11 key to step into the program. Let's press F11 to step into. We are now executing our program under the control of the IDE's debugger tool. The console window is open and the program execution is halted at the first line of the function main. This is represented by the yellow arrow on the left margin. We will call the line pointed to by the yellow arrow the current execution line. Here the current execution line is the first line of the function main. Observe the watch window at the bottom. Select the Locals tab. Notice that all the variables declared in the main function are listed within the watch window. However, none of them are initialized and some have arbitrary values. We will press the function F11 key once again to single step. The current execution now moves to the third line of the code because that is where the first executable line of the code is present. Here the variables are initialized. Note that the statement is not yet executed. Press F11 once again to execute the statement. Now the variable varname3 contains A and the variable varname4 contains 65. Since 65 is the ASCII value for the character A, both the variables consist of the same value. Note that varname5 and varname6 are not yet initialized. Press F11 once again to execute the last statement in the code. Observe the new value of varname5, which is 120. Also review each of the variables declared in the program and its value as shown in the watch window right now. See which variables contain expected values as initialized and those that contain arbitrary uninitialized values. Press F11 once again to end the execution of the program. You can see here the output window shows that the program has exited with a code of 0. We have reached the end of our demonstration today. The video has discussed the primary data types of C and how variables and constants are declared. We performed a small demonstration of how to set up a new solution and project in the Microsoft Visual Studio Community Edition and shown you how to use the debugger to single step through each statement of the program. In addition, you saw how to view variables declared in the program and inspect the values they contain at different stages in the program execution. We will continue to expand on these topics in our later videos. Please subscribe to our channel, like and share this video. In our next session, we will learn about C operators and demonstrate how to use them in a C program. See you then.